Hello students, in previous class we have learned about the human eye and how it is going to perform its function, and even we have learned that what are the defects are there in the human eye, how we can correct. Today in the session 2 we are going to learn about some of the natural phenomena which are taking place in the earth, and it is because of the refraction. In one of the lesson you maybe have learned, even in the 8th and the 9th standard, we have learned the meaning of the word refraction. Refraction is nothing but bending of the light when it is passed from one medium to the another medium. So let's see today how the refraction is helpful for us and what are the natural phenomena are going on with the help of the refraction. Okay, the natural phenomena such as the twinkling of stars, formation of rainbow, and some other today we are going to learn. So first of all, let's go through one of the concepts which have been explained by the Isaac Newton. He used the glass prism to explain this phenomenon. That is, as you know that glass prism is nothing but it is one of the piece of a glass with the two triangular bases and three lateral surfaces. And two lateral surfaces, as they will adjoin, there is a formation of one angle here. This angle we call angle of prism. And Isaac Newton, he passed the white light through the prism and he get a bend twice at the air, the glass interface and the glass air interface. The emergent ray is deviated by the angle to the incident ray. This angle is called as the angle of deviation. What do you mean by that? Is, as you know that in the refraction, if we pass a ray of light from one medium to the another medium, the ray of light it is going to get bent. But whereas here in the experiment conducted by the Isaac Newton, as he passed the white light, it has been bended. Once again, it has been emergent out, but the both medium are the same. But when it is emerging out, it is bending at one certain angle. This angle where the ray of lights are been bending from incident ray to the emergent ray, this angle we call it as angle of deviation. For your exam, then we can ask for one more question, what do you mean by the angle of prism, and even then we can ask the angle of deviation. So, what the experiment he conducted, as he passed the white light has been split into its constituent color. That phenomenon we call that one as a dispersion. And what the band of 7 color he got, we call that one as a spectrum. Why there is a formation of spectrum? As you know, different colors are exist, and all the different colors they have the different angle of deviation. Due to the different angle of deviation, there is a formation of spectrum in the white light. And during the formation of spectrum, red is the least deviated because it has a longer wavelength, and the violet is the most deviated, it has a shorter wavelength. And even then we can ask one question here, what do you mean by the white light? White light is the one which is split into its constituent color in the form of a spectrum. Even you remember, what do you mean by the word spectrum? Spectrum is nothing but order sequence of wavelength of radiation is called as spectrum. Did you got it? Can you go to observe here how he has conducted the experiment as he passed the white light? It has split into its constituent color, and the red is the least deviated, and I said the reason why it is the least deviated because it has a longer wavelength, and the blue is the most deviated because it has shorter wavelength. But once again, Newton, he has continued that experiment further. He wants to verify that just we have only the 7 color in the white light or there is the existence of more than. So, he placed a prism once again adjacent to that, but he found the same result. So, he once again he placed the prism in the inverted position and he got one of the new result. As he placed the prism in the inverted manner, as you can observe here, once again the seventh color has been emerged as a white light. So by this experiment, the Isaac Newton has concluded that white light is made up of 7 color. White light is the one which split into 7 colors. Did you got it? So let's move on. By using the dispersion, we can able to observe some of the natural phenomena in the nature. One of the natural phenomena, it is the formation of the rainbow. The formation of rainbow involves the 3 steps. One is a dispersion. As you know, what is the meaning of the word dispersion? Splitting of white light into its constituent color. Second is a refraction, bending of light when it is passed from one medium to the another medium. And the third one is internal reflection. Reflection, as you know the meaning, bouncing of the light is called as refraction. So let's understand how the rainbow will form in the sky. Rainbow is one of the natural spectrum appearing in the sky after the rain shower. It is caused by the dispersion of sunlight by the water droplet. In the atmosphere, after the rain shower, the water droplet which have been remain, they are acting as now as a prism. And the water droplet act like a small prism, as I told. They refract and disperse the sunlight. They reflect internally and finally refract it again when it will come out of the raindrop. Due to the dispersion of the sunlight, internal reflection by the water droplet, we see the rainbow color. Can you able to observe here? First, the sunlight will enter into the raindrop. As it enter, it undergo dispersion plus refraction. And internally, within the raindrop itself, it is undergoing the internal reflection. After the internal reflection, it will reflect. After the reflection, once again it is emerging out. Once again it is emerging out with the refraction. So for the observer, what the if refracted ray it has been came out from the raindrop, it will look like a rainbow. This is how the rainbow formation takes place. And rainbow formation, it involves the phenomena of dispersion. Did you get it? Can you able to see it is another one image how the rainbow will form because of the dispersion. Then let's move on to the next concept, that is atmospheric refraction. My dear students, you know that what is the meaning of the word refraction. And atmospheric refraction is nothing but refraction which takes place through the atmosphere. And you know, the density of the atmosphere will be vary from top to the bottom. As we come from the top to the bottom, the density of the atmosphere gradually get increases. And because of that, some of the natural phenomena also we can able to observe because of this atmospheric refraction. One of the natural phenomena is there is apparent position of the star. Atmospheric refraction is due to gradual change in the refractive index of the atmosphere, and the refractive index of the atmosphere gradually increase towards the surface of the earth because the hot air above is less dense than the cool air. So the light gradually bend towards the normal, so the real position of the star is different from its apparent position. What do you mean by this concept? Using this, I will explain you the two phenomena. One is, you maybe have observed some of the object by means of the hot flames or by the hot air. The object will be appear to be get flickering. What is the reason for that? It is the air above the hot surface become hot and rises above. As it get rise above, the space will be get occupied by the cool air. The refractive index of the hot air is less than that of the cool air. And due to the continuous change in the refractive index, object will be appear to be get flickering. So remember that we can ask this question for 2-1. In the same manner, the star also will be appear higher than their actual position because of the same reason only. So remember, atmospheric refraction is a phenomenon lagging behind, due to which the star appear higher than its actual position. Then by using the same phenomenon, there is another one concept we have. You can able to see that what is the reason lagging behind in this light, why the star appear higher than its actual position. And another one phenomenon, because of the atmospheric refraction that we will observe every day, is the twinkling of the stars. As we know, the stars are very far away from us, and the unit that we use to measure the distance, it is a light, and 1 light year is 10 trillion kilometers. And what is the reason that stars will twinkle? The twinkling of the star is also because of atmospheric refraction, the light, and due to the changing in the position of the star and the movement of the layers of the atmosphere, so the light from the star is sometime brighter and sometime fainter, and it is appear to be get twinkle. You know that the position of Earth is gradually changing, and even the atmospheric layers, which we have been divided into the 7 layers, the density is going to be get different. And due to the difference in the density and due to the gradual change in the position of the star, the light from the star sometime appear to be brighter, sometime appear to be dim. And because of this reason, changing in the position of the Earth and the changing in the density of the different layers of the sky, the star appear to be twinkle for us. Whereas in the case of the planet, they do not twinkle. Remember this difference, planets, they do not twinkle, whereas stars will twinkle. So what is the reason that planets do not twinkle? Even they will ask this question for the 2 mark. Planets are very closer to the Earth than the stars. The light from the stars are considered as point source of light, and the light from the planets are considered as extended source of the light. So the light from the planets nullify the twinkling effect. Planets don't have their own light. They are the collection of source of light. And because of the collection of the source of light, when that light will reach for us in the Earth, it will nullify the twinkling effect. Did you get it? Can you able to see in this light? Due to the gradual change in the densities of the layers of the Earth, the light it will be appear to be bent continuously. You know that the 2 differences from rarer medium to denser medium, and from denser medium to the rarer medium, how the light will bend. Because of that, the light will bend continuously. This is the one reason, and another one reason, as I told you, that is position of the Earth gradually changes. Because of these 2 reasons, for a star appear to be twinkle. Before going to the next concept, there are certain questions are there, they maybe can ask in exam as application based. One is, as I told you, when we pass a white light to the prism, it will split into its constituent color, whereas a less deviated one is the red. So then we can ask one question based upon that, it is, why the danger signs are made with the red color? The danger signs are made with the red color because red is a least deviated, and from very long distance it will be appear in the same color. It doesn't change, and it will not get scattered off by means of the fog or the smoke. Because of this reason, danger signs are made with red color. Okay, let's move on to the next concept. Advanced sunrise and the delayed sunset. It is also because of atmospheric refraction. The sun is visible to us about 2 minutes before the sunrise and about 2 minutes after the sunset because of the atmospheric refraction. What is the reason lagging behind? You can able to see during the sunrise, the actual position of the sun is here. But during the sunrise, the sunlight has to travel from rarer medium to the denser medium. So when the light ray pass from the rarer medium to the denser medium, it will bend towards the normal. So as it bend towards the normal, for the observer, the sun will be appear slightly above than its actual position. This concept we call it as early sunrise. In the same manner, during the sunset, the actual position of the sun is that. But during that time, the sunlight has to be traveled from denser medium to the rarer medium. So when the light rays is passed from denser medium to the rarer medium, it will bend away from the normal. As it bend away from the normal, for the observer, the sun appear higher than its actual position. So this is the reason lagging behind for the advanced sunrise and delayed sunset. Even this question can be appeared in your exam for 3 marks. Explain the phenomenon of advanced sunrise and the delayed sunset. Let's move on to the next concept. Scattering of the light. Splitting of the light is called as scattering of the light. And you maybe have come across in the 9th standard meaning of the word collide. When we pass the light by means of the collide, its path becomes visible. Or you can also say the scattering of the light by the colliding particle is known as a Tyndall effect. So by using this scattering of the light also, we can able to observe some of the natural phenomena which are taking place in the atmosphere. The Earth's atmosphere contains air molecule, water, droplet, dust, smoke, etc. As you have known from the lower classes itself, you have studied the air, what it is surrounding the atmosphere. It is nothing but it is a one mixture. When the sunlight passes through the atmosphere, the path of the light is becoming visible due to the scattering of the light by this particle. And whereas depending upon the size of the particle, what the light is going to be get scattered, the color will be going to be get different. How? If the particle size is very small, then it scattered the blue light. If the particle size is very small, then it scattered which light? Blue light. If the particle size is very bigger, then it scattered red light. Then it scattered all the light. All light in sense, it scattered the white light. If the particle size is medium, then it scattered the red light. Remember difference in this 3 size of particle. If the particle size is very smaller, then it scattered blue light. If the particle size is a medium, then it scattered the red light. If the particle size is very larger, then it scattered all light in sense that it's a white light. So let's see, by using the scattering of the light, which are the phenomena that we can observe in the nature. We can able to observe in this light how the Tyndall effect can be observed in different manner. So one of the natural phenomena that we can see every day and which is based on the scattering of light, it is the blue color of the sky. So in your exam, maybe we can ask a 3 mark, a 2 mark question also. That is, why the color of the clear sky is a blue? As I told you to remember, difference in the size of the particle. If the particle size is very fine or very small, then it's scattered blue. Medium, red. If it is very bigger or the larger size, then it is scattered all light. Okay, so let's see that why the color of sky is a blue. The fine particles in the atmosphere have size smaller than the wavelength of the visible light. In the very higher altitude of the atmosphere, we have very fine, very small particles than the wavelength of visible light. They can scatter the blue light, which have the shorter wavelength than the red light. And whereas the red light have the longer wavelength, when the sunlight passes through the atmosphere, the fine particles in the atmosphere scatter the blue color more strongly than the red color, so the sky appears blue. Remember, very higher altitude of the atmosphere consists of very fine particles, very small particles. And this very small particle, they have ability to scatter which light? Blue light. Hence, the color of sky appear blue. Whereas, if the earth had no atmosphere, there would be there would be not be any scattering of the light, and the sky would appear dark. The sky appear darker at very high altitude. For example, we can ask one application based question for you here. That is, for the astronaut, what will be the color of sky? For the astronaut, the color of sky is dark. For them, it will appear as a dark. The reason it is because there is an absence of atmosphere. There is no particle, there is no atmosphere to scatter the light. Hence, for the astronaut, the color of sky will be appear as a dark. Whereas the color of cloud is white. What is the reason?
Larger particles.
Yes, larger particle. The water droplets, as you know that water cycle we have learned in the 4th standard. The water molecule which will evaporate and they will condense to form the cloud. And during the rainfall, as they will condense to form the cloud, the water droplets size will be larger than the actual. As I explained you the 3 size of the particle, if the particle size is very larger, then the larger size particle they have ability to scatter
all light.
That is in sense that is white light. Hence the color of cloud is white. Remember that we can ask this one also for a 2-mark question. Why the color of cloud is white? Okay, next. You can able to observe here what is the reason that color of sky will appear blue. Then finally we have a last concept in your textbook, that is during the sunset and the sunrise, what will be the color of sky? At sunrise and the sunset, the sun is near the horizon, and the light from the sun travel through the thicker layer of the atmosphere and the longer distance through the atmosphere. As you know that during the sunset and the sunrise, the sun will come near the horizon. As you know the meaning of the word horizon too. During the sunset and the sunrise, the sun will be near the horizon, and the sunlight has to travel the longer distance and even through the thicker layer of the atmosphere. Near the horizon, most of the blue light and the shorter wavelength are scattered away. It will get scattered away. It is not going to be scattered through the earth's surface. They are scattered away from the earth's surface by the particles of the air and the red light of the longer wavelength. Because as I told you, when the sun is near the horizon, the sunlight has to travel the long distance. During the long distance, it has to send the longer wavelength. So longer wavelength of the light is which light?
Red light.
It's a red light. So during the sunset and the sunrise, the color of sky will be the red. Did you got it? Once again I will repeat. When the sun, during the sunset and the sunrise, the sun is near the horizon, and during that the sunlight has to travel the longer distance and the thicker layer of the atmosphere. In the thicker layer of atmosphere, in sense, there will be the medium size of the particle will be there. So as I told you, the difference in the 3 size of the particle, small, medium and the larger. If the particle sizes are medium, then it's scattered which light?
Red light.
Red light. So it is the sunlight has to travel the longer distance, then it has to send a longer wavelength of light. So longer wavelength of the light will be the mainly the red light. So during the sunset and the sunrise, the color of sky will be appear as red, the color. So here complete analysis of the lesson we have done. If any doubts are there, you can clarify with me. Wish you all the best and thank you.